So you might want to start on that before you guys share. You've brainstormed an idea. We're using whole group, big brain. And I'm going to switch it up just a little bit. I'm going to make each person at your table responsible for one part of this today. So if you're in seat 1, I want you to be the reader. If you are in seat 2, make sure everyone's brainstorming before you publish. In seat 3, make sure everyone's publishing with evidence. And seat 4, make sure that at some point you are taking a look at each other's work and advising each other on the quality of that work. The Big Brain is a group work protocol that helps students work together and to be efficient and to share ideas. One person reads the question. Everybody brainstorms together. Everybody publishes their evidence, writes in their journal how they solved it, giving evidence, and then people share what they've written with each other, actually the product. Switch papers, look at it, give each other advice, and then move on to the next question.
How much does it cost to buy 53 fraction calculators? How much to buy 27 scientific calculators? How much to buy 9 graphing calculators? How are we going to do this? Brainstorm.
I got 4,240.
Why?
There's 53 calculators, and the cost is 80. So 80 times 53.
I put 120 divided by 20 equals $6. So $6 per one calculator, and then 6 times 53. So that's the calculators, and then that gave me 380.
All ideas are valued, even wrong ideas. That disequilibrium is a tool that can be used for learning. So when we talk, it doesn't, my ideas are not valued just because they're right. The literal way that we make that happen is by using protocols for sharing, which really are protocols for actually listening to each other, creating the designed time to share your idea or to listen to ideas.
You go 120 times 2. That'd practically be 240, and then you add 10 to that, which would be 300, and from that you go 18, so 318.
Using this Big Brain protocol, it helps me assess students' understanding, because if we're working together as a group, I can float around the room checking in with groups, and I know that you're using this protocol, and I can see that your group is still on question 2, but most of the class has advanced to other questions. I can sit down and give you my time and attention and just kind of check in to see what's limiting your success and how can I help move the group forward. So what's some of the strategies that you use to fill in the rate table?
Then since we did half of 10 is 5, then we did half of 60 is 30. Then since it skipped by 5, then we made 30. Then we made it skip by 30. So we got 30, 60, 90, 120.
Okay, so that part of the table, I'm really understanding how you can use some of the information you already knew to find halves of, right? But how did you go from, and if you don't mind, I'm going to see if one of these guys can tell me, how did you go from that all the way back down to just 1?
I divided this number from that number.
When you say this and that, I'm really not sure what you're thinking, so.
I divided the number of calculators to the price of it, and then I got the low number, then kept adding it, and then when it came to 5, I just added 5, or when it came to 10, and from 5, I just added 5 more, and then from 15, added another 5.
Let me stop you real quick and let's go back. When he takes the number of calculators and does some dividing with the cost of the calculators. Do you know what he's finding out, Enrique? What's he finding out?
The cost of one calculator?
All right. Okay, let me ask a quick question. So I've heard you've brainstormed an idea for how to solve, and it's still a little hard to follow, isn't it? All those words and making the mental pictures. You've brainstormed some ideas here. You guys checked each other and you got the same answer. It might be a good time for you to just move on to publishing. You've got part of it published right now, and then seeing if they can see your work and look at your work instead of just hear your words. It might make more sense to them. So, you know, in terms of this big brain thing, sometimes you just have to say, oh, let's just move to the next step and let's see what each other gets, okay? And if we all have the same answer, that's pretty powerful, right? Okay.
Caesar, how did you get the price of the scientific calculator from 240 on and so on? Yeah.
I divided the number of calculators, which was 15, from 240. Then I got 16, and then kept adding on.
How did you get from scientific calculator?
I got the total cost for 5 calculators and multiplied it by 2.
So you used the same mathematical strategies as Caesar did?
Yeah.
That's good.
When you decide to get up to share, you don't have to send your whole posse up there. You can go in groups of 2, or you can decide whose paper. But would you look at each other's work right now and decide if you had to go up, whose paper would you take?
Yeah, we're taking a listen. That's the final answer. Don't we all have the same answer though? Yeah.
And stop. And the lucky table is table 7. Just a couple of the strategies you used. Not every single one, but just what are some of the strategies you used?
N stands for the number of calculators, times 6 the cost of one calculator.
And then that's what we did for the scientific calculators, is we took the number that they want times the cost per one, and we got the total cost.
So you have a responsibility to your group to advance the learning. And if we can do it at our table groups, we can do it as a classroom. If we can do it as a classroom, we can do it as a whole team. If we can do it as a team, we can do it as a school.